Well, good afternoon, everyone. It's my pleasure to introduce you to Devan Roper, who is our Mesonet manager here at the University of Maine. And Devan has a full-time professional appointment in cooperative extension and is very interested to join the Climate Change Institute for a number of reasons. But I would like to just mention that Devan was previously at the University of Southern California working as a lead technician on an air quality monitoring network in Los Angeles. And for our Mesonet, the new statewide weather station network, we hired Devan to lead the effort for installing 26 stations across Maine in support of agriculture and forestry to provide high quality research grade measurements statewide for use in climate and weather data products. And so, Devan, I'll turn this over to you. I just want to say that Devan has been doing an amazing job in terms of working with the instrumentation, uh, servicing the instrumentation, programming it, and we're really happy to have her with us here today.
Thank you, Sean. So I'm Devan Roper. I'm the Mesonet manager with Cooperative Extension. And today I'm going to be doing a technical overview of the Maine Mesonet as part of my affiliation talk for CCI. So just a quick rundown of what I'm going to be going over. I'm just going to get into my background a little bit, do a project overview for the Maine Mesonet, and then get into some instrumentation and communication that the stations use. And then lastly, just go over outreach a little bit. And my goal for this is just to get everybody an idea of what the stations are measuring, but also maybe some ideas on how we can collaborate with each other, because there's a lot of potential uses for the Mesonet. So I think we can all, it's just hoping to get some ideas from everybody. Okay, let's see. So I have a bachelor's in science in environmental science from Oregon State University. Shortly after graduating, I became a lab technician at USC, the University of Southern California. And my main role there was to manage a network of air quality sensors. But the lab I was in was a atmospheric and oceanic chemistry lab, specifically focused on carbon capture methods. So the air quality network the goal of it was to look at local levels of carbon dioxide in the atmosphere. But there also was an ocean side of this too that I was involved with. So we did some ocean alkalinity enhancement projects. So sometimes I was working in a greenhouse for looking at carbon dioxide. Other times I was in the lab processing ocean seawater samples. And then other times I was on a boat, maybe helping with like ocean coring. So it was a really great experience. I got to do a lot of different environmental and monitoring projects. And it was just great experience. I use all those skills today. But I have always been interested in meteorology and weather. So switching to a Mesonet was kind of a natural next step for me. So what even is a Mesonet? A Mesonet is a network of weather stations. Usually it encompasses a whole entire state, but sometimes we do have, for example, we know the Mount Washington network, Mesonet nearby. That is a regional Mesonet. The nearest one to us is the New York State Mesonet. They have a huge Mesonet. It's 100 plus stations. I'll get into the New York State Mesonet a little bit because we actually are collaborating with them. But Mesonet, the word itself, stands for mesoscale plus network, and mesoscale is on the 3 to 100 range, mile range. And one of the benefits of Mesonets is they provide real-time and local weather data, usually on the subsurface to 10 meters high for towers or 3 meters high for tripods. And they have a lot of meteorological benefits, but they also have a ton of agriculture benefits, which is one of the reasons why our Mesonet was started. So the Maine Mesonet was started by Dr. Lily Calderwood. She is a wild blueberry specialist on the team, and she saw a big need in the blueberry community for more agriculture data. The data is to inform integrated pest management and other weather-based decision tools for agriculture and forestry. So she just saw a need with the local farmers for more data. And then Dr. Sean Burkle, who is here today, he is in CCI and he is the climate and data side of the project. So he runs the Maine Climate Office website, which is where all our data is shown online, which I'll show that in a little bit. And then Dr. Phil Fanning is also on the project and he is an entomologist. He is on the pest management side of this project, so he does all the insects and the bugs and all that. Yeah, so our project is congressionally funded for 26 new stations. We already have 3 up in Maine, and I'll show those in a second, but getting into site selection. So the goal for this project is at least 1 station in every single county. Most of the sites will be towers, but some of the sites might need to be tripods if they need to have a smaller footprint. The towers use 3-foot ground screws, which is a little bit more invasive because the tripods, they just need a rod that's about 1 foot long to be put into the ground to anchor them. So site selection is in process. We do have a couple sites identified that we will be putting stations up next. But the goal for site selection is to have both agriculture and meteorological benefits. So we're working with the National Weather Service to identify potential sites that would really help their forecasting. And also Maine State Parks, we're working with them for fire data. But then we're also trying to put these stations on different types of farms. So we have, you can see on the map here, we have some potato areas, blueberry, and then mixed vegetables in the south. So the goal is to have stations in all these areas so that we're benefiting both weather and agriculture. Installations will begin again in May. It's currently too cold to put up stations, and I personally don't want to be out in the snow putting up a station. So we'll begin again in May when the ground has thawed. So here's some pictures of our towers and our tripods. The 3 towers are currently in our network and are up on UMaine research farms that are part of cooperative extension. Well, the first one is on campus. So this one is behind the Versant Astronomy Center, that field over there, and it's part of Witter Farm. And that was the latest station we put up. And then we have Blueberry Hill Farm, which is in Jonesboro, Highmore Farm in Monmouth, and then there is a 3-meter tripod at the Wyman Center. It's not officially a part of our network. I just use this for testing sensors before putting them out in the field. So moving on to instrumentation and how the stations are communicating with us. I wanted to start with the data enclosure because this is pretty much the brain of the station. It holds something called a data logger, which is where all the data is being stored from the sensors. It also is where all the cellular communication or satellite communication, if the station needs it, is happening. So the data logger is storing that data and then sending it cellular or satellite, and it has code already pre-programmed in it to compile data tables for us. So that's really nice that it does it already. And then there also is a pressure sensor in the enclosure. It does need to be shielded from the elements, so that's the only sensor that's like inside the actual enclosure. And something really special about our data loggers is they use serial communications, and specifically they use SDI-12. So this is a type of digital communication protocol that actually allows you to add sensors, multiple sensors to the same cables. So I have, in this example, 3 sensors here. They're all the same type, and they all have 3 different cables. So each of the sensors have a power, a ground, and a communication wire. And what I can do is actually combine like wires. So I'll go from 9 wires down to 3. So this is really great because it saves us space. The data logger only has so many. They're called screw terminals, which is where you're actually plugging in the cables into. So it saves me space, and it's also a really low-powered way to add a lot of sensors into the data logger. So you might be wondering, but how is the data logger distinguishing which sensor is what? So how it works is the sensors get a pre-programmed address. So I might make this first sensor A, second one sensor B, sensor C, and then I'll tell the data logger sensor A is a soil sensor, and you should expect this script of data coming from it that has like soil temperature in it. And so what the data logger will do is it will ping different sensor addresses one at a time, asking it for its data. So the sensors pretty much remain idle until it is pinged. it turns on, sends the data to the data logger, and then it turns off. And this is happening super quick. I still get data every second for these sensors. But this allows us to add up to, you can add up to 62 sensors on just those 3 cables, which is great because if you look at this picture over here, this is what all the cables look like. It is a bit chaotic. There's lots of wires. So I can take this and take it down to just 3 cables, which is amazing. So it saves me tons of space. And that's something really special about our setup. So how does the actual communication part work? So the data logger is compiling all that data, the 1 minute, 5 minute, hourly, and daily into data tables. Yes.
So when you say the 1 minute, are these averages by 1 minute, 5 minute averages,
Yes.
hours? So there's about one value in each of those tables for each
Yes.
sensor.
Yeah, it averages it for us.
Okay.
So that's all
It gives
happening.
it to you already to use.
Yeah, it's really amazing how much it does. Yeah, so it's averaging those into those data tables, and then it's transmitting those, this is raw data, to us via cellular or satellite. And then the New York State Mesonet, we're actually partnering with them. They do all of our quality assurance and quality control, because that whole process for checking the data could be a job all on its own. And we're partnering with them because they've been doing it for a really long time. So they check our data. They will flag anything that looks off, and then they'll tell me so I can go fix it. But partnering with them has been really great because they also can help us with troubleshooting if something looks wrong and they've seen it before, they can tell us what it might be. So they do the QA, the QC process, and then they send that process data back to us, which is displayed on the Maine Climate Office page that Sean runs. And then also they send it to our other users. So that's Subnautic, which is an organization that actually displays our data online as well. And then that gets sent to like the National Weather Service and so forth. So this here is a diagram of one of our towers. There's a lot going on, but I wanted to point out that most of the sensors are at the 2-meter height down here and also subsurface. And then we just have 2 sensors at the 10-meter height. And the sensors that are at the 10-meter height are also duplicates. So it's wind and temperature. We have duplicates down at the 2-meter height as well. The 2-meter height has a lot of weather and agriculture benefits. The 10-meter height is mostly weather benefits. The National Weather Service typically just uses our 10-meter wind data. They do use the 2-meter as well, and they will use it if we just have a tripod. For the temperature, though, those 2 duplicates, we can look at something called a temperature inversion, which I'll show in a second. But just zooming in on what the wind sensor looks like. So this is our anemometer. It is a wind speed and wind direction sensor. So again, they're located at the 10 and 2, and the 2-meter is typically just used for agriculture. But the National Weather Service might use it for wind chill data because that's surface wind that you are experiencing. So the 2-meter is also very important. Something that's a bit special about the sensor is it actually powers itself. It uses the wind power to power the sensor, and it is an analog sensor. So this is it's a bit different than our other sensors. It uses millivolts. It produces a millivolt value instead of an actual wind, like miles per hour value. And based on how high that voltage is the wind speed. So it works a little bit differently, but it's really nice because it powers itself. So I don't have to like put too much energy. Yeah, Dan.
So is there any chance that you'd have like a quiescent period when it would run out of power because it wasn't blowing any wind?
If it's kind of like if there's no wind, it's just 0. It still will report it, but it just will report.
But it doesn't. But if that's how you recharge the battery, could the battery run out if that went on long enough?
No, there's like no battery it's necessarily charging.
Oh,
yeah,
okay.
it
powers what it's doing at the moment.
Yes. Yeah.
So how does it report when it's not doing anything, when there's no wind?
It's producing 0, so it's 0 millivolts. So that will just the data logger
reported, so it feeds into some other system that's powered in another way.
If they're paying that device and it's 0, it means there's no wind.
Okay.
Yeah, so it's just 0.
Right.
Propeller's turning.
Got it.
Yeah. So temperature sensors. So these actually have what you're seeing here in this picture is a solar radiation shield that goes around the temperature probe itself. The temperature probe is just poking out the bottom here. So that just prevents any biases from occurring from sunlight directly hitting the sensor. But it still allows for ambient conditions. There's like little slots here that allow the air to go through. So it's still measuring ambient conditions. It's just protected from the sun and also any weather. So we do have, again, duplicates of these at 10 and 2, and that allows us to see temperature gradients forming. So I have a plot here of what that looks like. So this is at our Orno site here on campus. The orange line is 2-meter temperature in Fahrenheit, and blue is the 10-meter temperature. So this is from that day, I think it was a week ago or so, that it got up to 70 degrees on campus. It's very hot. So right here is 6 p.m. in the afternoon, and you can see the 2-meter temperature is dropping a lot faster than the 10-meter temperature. And this is almost a 10-degree difference that we're seeing. There could be a lot of things occurring here. A temperature inversion is when cold, dense air is getting trapped under warm air. And so this might be fog is occurring during this because the cold air is trapped underneath the warm and it's lower to the ground. So that's why fog's forming. And I do think temperature inversions, I think that could be a whole project on its own with the Mesonet data because we're only seeing this at our Orno site. So that's something somebody could look into more. I sadly don't have as much time to look into that, but yeah, I think it's just really interesting to see just how there's such a difference, though it's 10 degrees is a pretty big.
And just there, everywhere else did.
Yeah.
Virtually identical.
We do think it might be because the station itself has a hill nearby. So maybe it's because it's like it's in kind of a valley.
Put a thermometer on top of that flat.
We're trying to. Yeah, we're trying to. Yeah, maybe. I'll go out in the morning and just put a temperature probe on the hill. And yeah, but I would have to go at like 5 a.m. But we'll see. Yeah, so we're thinking about putting a temperature on the probe on the hill. So moving on to our humidity sensor. These are also in those solar radiation shields. So that's why they look exactly the same as the temperature probes. But what we use this for is to calculate dew point. So that's the saturation point of the atmosphere. And these are located right next to the temperature probe because you take relative humidity and temperature defined dew point. So this is our snow depth sensor. This is one of my favorite sensors we have because it's a sonic wave sensor. So it creates a clicking noise that if you have really good hearing, you can hear it when you're next to it. So that noise travels, it hits the snowboard that's on the ground here. And then that snowboard reflects it. It goes back up to the snow depth sensor. And based on how long it takes for that noise to travel from the snow depth sensor to the board and back, it creates a depth, a distance. And so we use the snowboards because vegetation is changing throughout the year and I need a stable reference to compare to. So I'll show you what this calculation looks like. So we'll take that reference data and then I'll subtract any values after that. And if snow is occurring, the ground is getting higher up to the sensor. So it should be a value that's greater than 0.
It doesn't matter if the snow has different amounts of water or density.
No, yeah, so that's just there are sensors that measure that, but ours just does snow depth, purely just snow depth. So these are 2 plots just to show you after that calculation happens. So this top one is from our Monmouth site, and this is Jonesboro, and this is from the same weather event. So this is in meters. I can't do the inches calculation off the top of my head, but you can see there's just a large increase here. And then I have seen a lot of our sites, there is usually a decrease after a snow event. This is right here, noon. So maybe the sun came out. But also if it's a really windy storm, that will blow the snow around. So that might impact the snow depth variable. So this is our rain gauge. We did get the best rain gauge you can buy. And it can hold up to 30 liters of precipitation. So what's really nice about that is I only need to empty these out about twice a year. Another thing that's really special about them is they have a heated ring right at the top here to prevent ice bridging from forming. So an ice bridge might form if, let's say, like snow packs on the top. It might ice over, and then no precip is going to go inside the rain gauge. So that's going to impact our calculations. So having that heated ring is really great. It does take up a lot of battery power, which I'll get into in a little bit. And another thing about these are this ring around with those sheets of metal, that's called a alter shield. And what that does is it just redirects wind from the top of the actual rain gauge. So that just prevents rain from blowing on the top of it and preventing precip from also going into the rain gauge. So this is a pyranometer, is a shortwave radiation sensor. So this is measuring sunlight. This can be used for like a UV index. It can be used for estimating how much sunlight vegetation is receiving. This is more used on the agriculture side, but you can also use it to estimate how overcast the area is.
Does it measure both direct and indirect?
I think it's just direct. Yeah. So these, moving on to our subsurface sensors. So these are our soil sensors, and we have them at 5 centimeters, 25 and 50 in the ground. They measure both temperature and soil moisture at the same time. And these are very useful for the agriculture side of things. They can tell us if there's a drought occurring. They can tell us how much water maybe farmers need to use when they're watering their plants. And these also will tell us when the ground is frozen, but how deep does that freeze go, which can be really useful. Okay. So this is a leaf wetness sensor. Its job is just to mimic the conditions that nearby canopy is experiencing. That's why it's shaped just like a leaf. And this one's a little bit different because it's measuring on 5-minute intervals. And what it does is it looks back at the last 5 minutes and it produces how many of those minutes were there wet conditions or dry conditions. So it's a little bit different, but it does give us a good idea for how wet the vegetation in the area is. And it's angled so that vegetation won't, precipitation won't just sit on top of the leaf wetness sensor. But it's really useful for more the agriculture side of things.
Does it absorb any water, or is it
No.
completely like plastic?
It's plastic, yeah. So the water will just run off of it. But yeah, it does have some texture on one side of it, so it sometimes like catches precipitation.
Leaves do too.
Yeah, so exactly, yeah. So it's designed in a way just to mimic different types of vegetation. So you might be wondering, how is all this powered? There's a lot going on. So we have a power enclosure on all of our stations that holds a battery and also a charge regulator, which the charge regulator's job is just to mitigate the power between the solar panel and the battery, because you can overcharge a battery. And if you overcharge a battery, it's just really bad, can cause fires, etc. So the charge regulator's job is really important. And the system is fully reliant on the battery at night. And then the solar panel is charging it throughout the day. Also during storms, the system is partially reliant on the battery. Even during storms, some of our solar panels are still charging a little bit, which is really nice.
So when they're both charging the battery and running the system
Yes. Yeah.
during the day. Yeah.
Yep. Yeah, so I wanted to show an example of what power draw looks like during a storm, specifically with that heated ring from the rain gauge. So here I have a plot of red. The red line is battery voltage from our Jonesboro site. Blue here is precipitation. And then these orange highlighted areas are when that heated ring was indicated that it was on. So
it turns on when it's below a certain temperature and senses
Yes.
precipitation.
Yep, exactly. Yeah.
Okay.
Yeah, we do that because if it was on all the time, it would drain our battery.
Right.
No reason.
Yeah, yeah. So it would be too much. So the voltage here, this is 13 right here to give perspective. The batteries are 12-volt batteries. So 13 is still a well-charged battery. I'd be worried if it got to 12.2 because that's a 50% discharged battery. And if it goes below that, it's very hard to recharge a battery after it's halfway discharged. So this is just to show, you can see right here, we'll let me backtrack. This curve is a natural thing we see at the end of the day. So this is the sun is going down. So you can see that the battery is no longer being charged. And then right here, we have a precipitation event occurring. So this has a strong dip right when that happens. But it does level out. And this is, again, still 13. So right now, our system is well equipped to handle this precipitation event. But again, if the heated ring was on all the time and there was no solar panel charging the battery, our battery would last about 2 days. But with this, and what I do to estimate how long a battery is going to last is I take real-time data. So I'll take how often the heated ring was on from all of our stations. I just used January for our calculations because I thought that was pretty representative of how winter is here. And with that, like how often our heated ring is on and how much our batteries are being, how they're dealing with that, our system would last about 2 weeks, even without solar charge, just because the heated ring isn't really turning on too often. And after it turns on and the heated ring heats up to a certain level, it turns off. So it so far is working out really well.
As a routine matter, how often will you look at the batteries and the power situation in each of these stations? Because if something catastrophic happened, you'd want to get there, fix it, right?
Yeah, I do. Whenever I check the stations, which I check them almost every day, I do check the voltage. But our system is also designed to, if the battery goes to a certain point, below a certain point, it will warn us.
Oh, okay.
So also the New York State Mesonet with pellets too. Yeah.
Yeah.
So it will like flag if that happens, which is great.
What's the battery life? Yeah, I assume you have to replace them every once in a while, like a car.
It's about 5 years. Yeah, so they're pretty good batteries.
And you have a schedule for replacing it sort of maybe every 4 years, so that they don't die on you?
Not yet. I think we're still, yeah, yeah. What we're gonna see how these handle things, but I think other Mesonets, they use similar batteries as us and they do 5 years. So I think, yeah, I think we'll be okay. But I eventually want to add in cameras, and that is a whole other strong power draw. I know a lot of people want images from all of our stations. I do too. I think that'd be very cool. But that takes a lot of energy. So I'm currently figuring out if we can add cameras and what that would do to our battery life. But
You might need to get a whole separate battery.
Yeah, I wonder if you
Yeah.
had a different solar panel and different battery to run that.
I might need to get 2 batteries is the thing.
Because if you lost the camera, it would be less catastrophic than losing the.
Yeah. Weather.
Yeah,
see.
yeah. Exactly. But the cameras do add another level of security too.
Yeah, you can
Yeah.
see if anyone came up. Yeah.
Exactly.
You also see animals.
Yeah.
Animal activity.
Yeah, a lot of people post that, the animal trail cams, and
Yeah.
get really good ones, you could sell it as a bargain.
Yeah.
Mine.
Yeah, I think there's so many benefits to cameras and like on the education side of things too. I know the New York State Mesonet, they have all their cameras up and they also have pictures of like water spouts or like a moose or something. It's like crazy things that happen. So I would love to set up cameras, and that's currently what I'm working on in the meantime till installations begin in May. So we will see.
Heard from forecasters that they really like being able to see the real-time weather.
Oh, yeah.
And so they're really keen on the Caribou and Gray offices are keen on if we're able to install cameras for that reason.
Yep. So for maintenance for all the stations, I go back to all the stations at least twice a year. And what maintenance looks like is you do need to tilt down the tower. You can see what it looks like here. I'm currently working on a truck winch situation, so I would be able to do this on my own. Currently, we need at least 3 people to lower them down because the tower itself doesn't weigh a lot because it's aluminum, but with everything on it, it does weigh over 200 pounds. So it's kind of a lot. So a winch though would be perfect. So I'm working on that right now. Because we have to lower them down to get access to those 2 sensors at the top. Just because they need to be cleaned. And then there's also calibration intervals that I'll need to replace sensors at.
So I take it a winch would be a lot cheaper than a bucket truck,
yeah.
although you could probably rent one of those.
I think other Mesonets use a winch and it has worked really well for them. So, I mean, it's only, I don't need a winch that can like move a truck or something. So it's, yeah. So it's not like I have a super heavy duty winch. I am getting one that is really strong just in case something happens. But yeah, so the winch and sub I think will work really well. But other things for maintenance is cutting vegetation around the stations. And then also again emptying out those rain gauges. For the fall, maintenance looks a little bit different. We will put antifreeze inside the rain gauges to prevent ice forming at the bottom. So that is the main extra thing we're doing. I'm also checking all the cabling because sometimes animals might try to bite the cables.
They do, with red squirrels.
Yeah.
You know, my daughter's car had like $4,000 of damage.
Oh, no.
Because they're vegetable-based coating.
Yeah. I've heard other Mesonets use WD-40 on the cables because it makes them taste bad, which I think is really funny. So yeah, we're gonna put fencing up around a lot of our stations, and this picture doesn't show it, but I do have some hardware cloth around the base of our stations just to prevent animals from getting into the really important cabling. Yeah, so that's what maintenance looks like. And then so for calibration, we are following the American Association of State Climatologists recommendations for calibration, which the AASC, they are the ones who are certifying a Mesonet as a Mesonet, an official Mesonet. So we follow their best practices so that we can get that certification. And every sensor except the rain gauge needs to be recalibrated every 2 years or replaced. The rain gauge is so good that we actually don't really need to recalibrate it that often. It just needs software updates. And you can check it by having like a known volume of liquid, put it into the rain gauge and just do a manual check like that. But that's about all it needs, which is amazing. All the other sensors though, they do need to be checked and then also occasionally rotated out just to verify that they're still working correctly. And this varies from sensor to sensor. Like our humidity sensor has a chip in it, and all I have to do is take off a cap, replace the chip that's calibrated, and that's it. So that's great. But the temperature sensor, that one does need to be taken back to the lab and manually checked.
Do you have like alternate ones that you put in? So
Yes.
you're constantly rotating
Yep.
them back to the lab?
Yep, exactly. So that's part of the sensor rotation to make sure we're never losing data, is I will just take one that needs to be recalibrated, put a calibrated one in. I think sensor rotation is also good. Just it gives me time to check the sensor, but also just it's not a bad idea just to rotate them occasionally. And then I'll also co-locate sensors every 2 years. So put them right next to each other just to verify nothing is super off. So installation is a long process. It takes 9 to 10 hours, depending on how many people are available. And this right here I just wanted to show what just the rain gauge looks like to put together. So it starts out just like this. And this is Patrice, one of Lily's grad student, putting together the rain gauge here. And this right here, the alter shield, it's all individual little metal pieces. So I think that part takes the longest to actually put together. There's also some digging involved because we got to get those soil sensors into the ground. We do bury our cables as well. So we have to dig a trench between the rain gauge and the tower to put all those cables in the ground, and then we put the soil sensors in. And then you can see here, this is me putting together the wiring for the data enclosure. There's a lot of wiring involved. I am doing that now beforehand, just because it saves a ton of time. But yeah, so the whole process is
Probably better conditions to do it.
yeah, for sure. Yeah, so the whole process takes 9 to 10 hours, and there's just a lot of little pieces happening. Like I need to orient the wind sensors to east or west, depending on what the station is facing, so that we know that they're going in the right direction. All of our stations are oriented to true north, so I need to make sure that is exactly right. And then there's the cross arms need to go up and the solar panels. So it's a long process.
Do you have a checklist?
Yeah, I do. I do have a checklist because it is so many little things.
Forget something, have to redig it all up and start all over again.
Yeah, exactly. Yeah. But something with installations, it is a lot of work, but it is a really good opportunity for CCI students to get involved with Mesonets. I'm currently looking for more undergrads to
If
help.
you want to put out a message to the grad students, just send me one and I'll send it.
Okay.
I have the list and I can send it to them.
Okay, sounds good. Yeah, so we are looking for extra hands for seasonal workers this summer.
Are these paid seasonal? I thought they were.
Yes,
You told
yeah.
me that, yeah.
Yeah, it would be hourly. Yeah.
Did I already do something else? No.
Yes,
I did.
yeah, we already put flyers
Yeah.
out.
But you can research it.
Again, yeah, people are back from break. Now they're beginning to think about summer.
Yeah, okay. Yeah, so I think it's a really good, like field work is a really great thing to add to your CV, specifically Mesonet, because if you're, wanting to be in the climate and weather world, it looks great to have this experience. We also did a tripod setup at the Maine Agriculture Trade Show this past January with Cooperative Extension. So I have a little traveling tripod setup here. And I bring a fan and people can try out the wind anemometer and see how it works. And kids really like it. Adults think it's interesting, but some people thought I was selling solar panels, but that's okay. But yeah, a lot of people were really interested and they got to see the Maine Climate Office website that Sean runs that has all of our real-time data and our stations up. We are working on a more agriculture-focused webpage that might just be a little bit easier for farmers to get the specific agriculture data they need and download it. But the Maine Climate Office looks like this, and it has all of our stations, just the 3 now, but slowly it will grow. 3 stations up, and you can see all the real-time data that it's producing. I think the lowest frequency you can do is 5 minutes, but yeah, it's up and running currently. So if anybody's interested in looking at that, and you can also download the in a CSV format. I think there's some other formats you can download as well from this web page, which I am currently working on a educational outreach resource for teachers that would allow them to teach what Mesonet data is in the classroom. Because I think Mesonet data is a really great way to teach basic plots, but also teach a little bit of coding as well if the kids are old enough. So working on a resource for teachers that they can bring this data into the classroom so that kids can maybe make the connection of, oh, I went outside, it felt cold, but I can see it on the station is below 32 degrees or something like that. So there's plenty of outreach opportunities for the Mesonet that I want to explore. But it's all in process since we're still pretty new. But yeah, that's all I had for today. If anybody has questions. Oh, I see somebody raised their hand.
Maybe see online first, then we can just chat.
Yes.
And I am
Yeah.
It'll be 5 minutes. I've got to get.
Can you hear me?
I see Ivan, you raised your hand.
Yeah. Can you hear me?
So you can meet.
Oh, I can't hear.
Can you hear me? Can you hear me?
Tomorrow, so I work at home.
Well, oh, okay.
I can
see now.
actually
Sorry,
hear
I
you,
can't hear
Ivan.
you. Hold on 1 second.
Oh, okay.
If my sound is messed up.
Well, my question had to do for whoever can hear me. Is do you
Oh, I
know
can
what's
hear you now.
Can you hear me, Devin?
Yes.
Okay. Great presentation. Really interesting to see that. It would have some background in monitoring stations, and so those are very impressive. I'm a soils guy, so let me ask a soils question though. Do you know what the soil series is, and is there a profile description for where the soil sensors are?
So what I'm doing currently is I didn't know this putting this sensors in because I am new to soil sensors. But we are going to take soil samples from all the sites to get like the texture. I don't know if that will be like a full profile. So you actually would probably maybe know more about this, but yeah, so that's the minimum we're doing. We are getting a soil texture sample from each of the sites.
Okay. Well, undoubtedly on the farms, at least, they know what the soil series is. So it will be good to know what the series is and know that profile description so that you know where the sensors are relative to the horizons. Because if you're comparing 2 soils that have a 3 or 4% difference in organic matter relative to temperature and moisture, it's to some extent it's apples and oranges, but if you know that, then you can put it in that context.
Okay.
But anyway, just food for thought.
Yeah, no, thank you. Yeah,
Yep.
what I'm going to do is take samples from each of the different depths that all the sensors are, and send them for sampling. So
Yep. Yep. Great. Thanks. I think Brenda had her hand up too, didn't she?
Yeah, I have a question. How quickly are the data available online? Is it it's not real time, is it? It must take New York a little while to process them, or how quick are the data available?
It's still, I think it's, Sean, do you know?
Near real time.
It's near real time. Yeah, it's 5 minutes. And then once I put a station up, that the data is available immediately as soon as I turn the data logger on as well. So the whole process is really quick. They're QA, QC. They do have an automatic process, so it's doing it really fast. They do manually check the data for us as well, which maybe takes a little bit longer, but yeah, so it's available really quick.
Yeah,
Great.
I was
Thanks.
within about 2 minutes because I
Within 2
have
minutes.
my script's time to ping the New York State Mesonet API 1 minute after. I think 2 minutes. So 2 minutes after the 5 minute interval is when I grab the data. So their whole process only takes about a minute.
Wow, that's fantastic. Yeah, thank you.
Okay, there's a question in the chat from Melissa. Says, what regulatory issues are there, local, any broadcasting or not, since it is different than something like radio? We haven't had too many broadcasting issues. We are using we're using Verizon specifically, and they have been really great. We might run into some issues with satellite just because it takes more energy and it's slower. But besides regulatory issues, I don't really think we've run into too many.
Not so far.
Yeah, not so far, luckily. Okay.
So what's the bandwidth on a cell phone? Because you have 1200 for the serial, right? It's pretty small.
Yeah, I
So
think
you
it's
go beyond capacity.
5 Gs.
Oh, so you.
Yeah.
Yeah, because the actual amount of data that's written is pretty small.
It's like is it megabyte?
I don't think it's that.
No.
I think it's.
Max a day.
Oh, well, I was thinking per transfer.
Oh,
rate.
per.
I think we probably measured in kilobytes.
Because it's just the text of the data table, so it's very small, yeah.
Reason I'm asking, if you're adding the webcam.
Mm-hmm.
So saturating,
it's
then
different.
let's say you want to add like other sensors in there, because I can think, what do you get at, like a GPS? Because if you get a good GPS sensor, you can actually study atmosphere above it.
Yeah, I don't know if our systems could handle that just with the current setup. I know for like cameras, the data logger itself has a special retrieval process that it can get like HTTP files and it can store them and then send them. So that's how I'm going to do it for the camera. But that's just specific. The data logger just has that special, but it might take, we'll have to see how much energy. And I'm gonna set it up so the camera turns on, then turns off every like
Another way
5 to 10
is
minutes.
Keep it on the load, don't send it, and then just, download it like every 6 minutes.
Well,
But yeah,
for the video camera, or the video image, we want those near real time.
Yeah.
that's the goal.
If we've had this discussion, do we get a snapshot every 5 minutes, or every 10, or maybe 15 minutes to save power?
Yeah.
People do it a lot in the volcano observatories, so you can talk to Alaska Volcano Observatory people.
Okay.
And
Yeah.
they do the webcams on volcanoes and also seismic data. And that's what they do GPSs, because the reason is the satellite data, if you process it right, you can actually get the atmospheric property above you, which is incredible value.
Yeah.
So
Okay.
if you have a spot, that's really a lot of stuff.
Okay.
Then also particles, like we already done it, so technically if you add it at some point, I'm not saying right now, but
Yeah.
that your expansion.
New York State Mesonet does some of that.
Yeah, they use GOES satellite, but they have like enhanced sites. But I don't know if we have the funding for that right now.
Well, we need to look ahead, because
Yeah.
the world change.
Yeah.
Another thing I was thinking, teaching. Like, is there anybody teaching class like this at University of Maine here? It almost like feels like it's basically hands-on experience, right? That's what they're talking about. Where you go like and discuss in general, like how do you collect data?
Yeah,
What's the data quality, how you clean it? And I can see all this, like other units might be interested in it. And
Yeah.
I'll run it on the CCI umbrella because we have CCI.
Yeah. so
No, I mean,
that's a
like,
good idea.
Because we have a ability to offer some classes, right?
Yeah.
To some degree.
Okay, yeah, that's a good idea. I know, like, coming from air quality, it's like a lot of environmental networks, they just cross over so easily. Like it's all the same concepts with,
But there is a big push right now to do that, right? And I think also the School of Earth and Climate Science is potentially interested in this type of things, I know, for sure. They'll cut on. So have something going.
yeah. Okay, so that's good to know.
Definitely big story.
And I know
Keep the
once,
Prince class, just expand. No, but I mean, the idea here, you already have a class name. You don't need to submit a new class.
That's true.
And then you can just keep going under the same number, and then you don't have to do a lot. Yeah, something like that. It could be. So how the first umbrella first, and then keep going.
Yeah.
Something,
that's a good idea.
I don't know, right? Kirk knows more probably.
Yeah.
Than probably, that was your.
Right. Well, looks like there's no other questions, so.
Thank you.
Thank
Oh.
you very much.
Oh, there might be one more. Oh, it was just a comment. Okay.
Okay.
Thank you, David. All right. Thank you guys on Zoom.
Thank you everyone for joining.
Yeah.
Great talk.